lessons 6, 7, and 8 are going to have some similarities. And in lesson 6, we're not going to directly use the calculator or Desmos to come up with equations. And so make sure that when you're doing each particular lesson here in 6, 7, and 8, that you're following which type of thing you're supposed to use. So for lesson 6, you're going to find a line of best fit from a given list of points. And you're going to find a linear equation, and you're going to make predictions based off of that. So a few things. One thing you're going to be asked to do is to graph your sets of points. And then sometimes asked to talk about the correlation of those points. Do they make a line? Do they not make a line? Do they make a curve? Curve stuff we'll talk about in later on chapters. Since we're dealing with linear stuff here, we're going to concentrate on that. So if you take a look at this first one over here that's going up and to the right, the points have a positive correlation because they are going up and to the right. Now, I can't draw a single straight line through all of the points, but I could draw one through right around here. Actually draw that in, somewhere like right about there. That would come close to all the points, but not quite hit them. And the same thing with this one over here going down and to the right. I could draw a line that would come close to all those points, and that would have a negative correlation. So as points go up and to the right, they're positive correlation. Down and to the right, they're negative. Now this one here, can't really draw a line. I mean, I guess you could sort of draw one here, but that's not a very good representation of that. You can tell that the points start to go up and they come back down. So that would be considered nonlinear. We'll eventually use the calculator to determine whether a linear fit's a good one or not. That'll be in the lessons after that. All right, so the line that we're going to come up with is what's called a regression line, sometimes called the line of best fit, and it's going to be a line that best models the data. Now, with the way that we're going to do it today, by not using the calculator, the points that I pick will probably be different than the points that you would pick. Because of that, your answers are going to be slightly different. But that's kind of the whole idea with this, is to say, well, if you pick Atlanta and St. Louis and I pick San Francisco and Arizona, our answers are going to be slightly different. The question is, how different are they? Okay. So in this particular example, and you don't necessarily need to know sports to be able to do some of these problems here, on-base percentage is the percentage of times when you get an at-bat that you actually get on base. So Atlanta, a little more than 33% of the time they get on base and so on. You can see each one here. They're all in the 30s. And this is the runs that are scored. So the question will be, is there a linear correlation between these two things? All right, so the first thing that you're asked to do is to draw a scatter diagram of on-base percentage versus runs scored. So I did that already. I drew that down here. Okay, so on the bottom here, this is on-base percentage. I should label that. So going away, on-base percentage. Over here is going to be run scored. Okay, I went up by, so this says 680 right here, so I went up by 20s on here, and I went up by 0.2 over here, making sure that everything gets covered, and then I just took and graphed each point to draw your scatter diagram. So you can see as the on-base percentage goes up, the runs typically tend to go up as well. Now, again, it's not a perfect linear relationship, but you can see that it does go up in that direction. All right. Second question says to select 2 points and find a linear model that contains those 2 points. All right. I am going to pick Philadelphia. Oops. Sorry. Let's undo that. I'm going to pick Philly. Here, let's just do this. And I'm going to pick Pittsburgh. Okay, so I'm going to have in this case, the runs scored are going to be the y coordinates, and the on-base percentage is going to be the x coordinate. So I'm going to do slope y2 minus y1 over x2 minus x1. Okay, so for this one, 865 minus 691 over 334.7 minus 32.7. All right, and if I take that and I plug that into the calculator, you're going to end up getting 87. Okay? So then I'm going to pick one of the 2 points. I'm going to pick Philadelphia, and I'm going to plug that into my slope, point slope form, excuse me. So I would have y minus 865 is equal to the slope of 87 times x minus 34.7. Okay, I'm going to distribute the 87 in and then add the 365. So when I distribute in the 87, I will have 87x minus 3018.9, and then I'm going to add the 865 to the other side. And so then my answer on this, I'm going to go over here to my next problem. Y is equal to 87x minus 2153.9 when I do the 3018 and the 865 together, negative 3018. Okay, so that's going to be my equation. So now I'm going to use that equation to predict the number of runs scored with an on-base percentage of 38.2. So I'm going to take 38.2, plug that in for x, come up with the answer. And when you plug that into your calculator, you will get 1,170. Okay? Now, just to go back with this idea here, if you would have picked Colorado and Milwaukee instead, you would not get the exact same equation right here. You would get something that's slightly different. And when you would then go to do this answer, you wouldn't get 1170. What you hope is that, the two that you pick give you approximately the same answer. So if you're comparing to a person that's working next to you, your answers would be the same, or close to the same, excuse me. When we go to use the calculator is going to take all of these into account and come up with an equation that'll be the same for everybody. So again, we're just kind of showing that, what one person finds, the other person finds isn't going to be the same, because again, you're picking, what if Philadelphia would have scored, 3,000 runs instead of 865, but all the other ones were in this ballpark here, and Philadelphia would have been the team you picked. Your answer is going to be extremely different. All right, last thing, interpret the slope of your linear model. So the slope of mine being 87 here. So with it being 87 over 1, essentially every time the on-base percentage would increase by 1, the runs scored, erase. Runs scored will will increase by 87. Okay. So that is how you do lesson 6. Let me know if you have any questions.